Today we are looking at an interesting topic in physics, atmospheric pressure. I'm going to be explaining some things to you today, after which we'll solve simple calculations. It's very simple and I know you're going to enjoy it. Just open up your mind and watch this video to the end. What is atmospheric pressure? Atmospheric pressure is the pressure exerted on the Earth's surface by the atmosphere. The atmosphere is the whole volume of air surrounding us. It is made up of mixture of gases, water vapor and dust particle. Let me show you this about the atmosphere.
Welcome to today's class.
At sea level, the atmospheric pressure is 760 millimeters of mercury, or 1.013 times 10 raised to the power 5 Newton per meter square. Below the sea level, pressure increases. Below the sea level, pressure increases. Above the sea level, that is the atmosphere, pressure decreases. It is very important you note this. As we go higher and higher through the atmosphere, pressure decreases, while below the sea level, pressure increases. We are going to apply this understanding of atmospheric pressure in solving calculations. But before we go to the calculations, why is it that we don't feel the atmospheric pressure? We don't feel the atmospheric pressure because the cells in our body maintains a pressure, let's call it the blood pressure, that balances this atmospheric pressure. That is why we don't feel the atmospheric pressure around us, because the cell of the body maintains a pressure, let's call it blood pressure, that balances this atmospheric pressure. Let's look at the following calculations. The first example, the atmospheric pressure due to water is 1.3 times 10 raised to power 6 Newton per meter square. What is the total pressure at the bottom of an ocean 10 meters deep? Density of water is equal to 1000 kg per meter cube and G is 10 meter per second square. Let's write out, to solve this problem, let's write out all the parameters we are given. Given that the atmospheric pressure is 1.3, atmospheric pressure is 1.3 times 10 raised to power 6 Newton per meter square. And the height is 10 meter. Below sea level, H is 10 meters deep. That's why we are writing this as H. Then density of water, we can use rho. Density of water is 1000 kg per meter cube. And G is giving us 10 meter per second square. We want to find the total pressure at the bottom of an area. Remember that total pressure. And this time around, remember I told you that pressure below sea level increases. So it's going to be pressure due to that height, the atmospheric pressure, plus pressure due to that height, which is H rho G. Why is the total pressure sum of atmospheric pressure plus pressure due to the height? Because it is below sea level. Below sea level, pressure increases. Now, the atmospheric pressure is already given. Let's get H rho G. Let's get this. That's H is 10 times G is 10 times density of water is 1000. So that will give us times 10 raised to power 5. So we have gotten this as 10 raised to power 5 Newton per meter square. Remember, this is pressure. So let's go back and say that the total pressure P will be, atmospheric pressure plus pressure due to height. Atmospheric pressure is given as 1.3 times 10 raised to power 6 plus pressure due to height, which is 1 times 10 raised to power 5 Newton per meter square. We go ahead and sum up everything. We will have 1.4 times 10 raised to power 6 Newton per meter square. That is the final answer. Let's look at another example. Calculate the length of the liquid in a barometer tube that would support an atmospheric pressure of 3.06 times 10 raised to power 5 Newton per meter square. If the density of the liquid is 1.36 times 10 raised to power 4 kg per meter cube, take G to be 10 meter per second square. In solving number 2 example, giving pressure P as 3.06 times 10 raised to power 5 Newton per meter square. Density of the liquid, rho, remember rho is for density, is given as 1.36 times 10 raised to power 4 kg per meter cube. That's the unit of density. Then G is given as 10 meter per second square. We want to get the length of the liquid. It's very easy. Don't say it that is hard because of that word length. Remember that pressure is equal to H rho G. The height and the length, they are measured in meters, so we are looking for the height. I know some people will look at it as if they have not seen it before because of that word length. So if we make H the subject of the formula, divide here by rho G, divide here by rho G. So P over rho G is equal to H rho G over rho G. So the unknown will stand out, H. H is equal to pressure over rho G. Pressure is 3.06 times 10 raised to power 5 over rho is 1.36 times 10 raised to power 4 times 10. So the final answer will be 2.25 meters. Try this assignment. What is the length of the liquid in a barometer tube that would support an atmospheric pressure of 102,000 Newton per meter square if the density of the liquid is 2,600 kg per meter cube? Take G to be 10 meter per second square. Please try the assignment and vote for your answer in the community section. I hope you enjoyed the class today. Please like this video, drop a comment, and share this video. Thank you.